Okay, hello students. In this video, I would like to prove a few more identities. That is y sine inverse of x plus cosine inverse of x is pi by 2. And the same thing is tan inverse of x plus cotangent inverse of x is pi by 2. And y cosecant inverse of x plus secant inverse of x is pi by 2. So that's one group of identities I want to prove. Then there's another one we need to prove. Y sine inverse of x plus sine inverse of y is sine inverse of x root 1 minus y square plus y root 1 minus x square. So that we'll see what is the reason. We'll also see then if it is plus, if it is minus, then this is minus. Then if it is cosine inverse of x plus cosine inverse of y is cosine inverse x y. But this time, if it is plus, too many formulas. If it is minus, sorry, if this is plus, then you take minus, yes? And then it is square root of 1 minus x square and 1 minus y square. So if it is minus here, then this will be plus. Okay, then there's one more thing also you should know is, if I have, there's another group, third one is, if I have 2 tan inverse of x, this is same as sine inverse of x, 2x over 1 plus x square equal cosine inverse of 1 minus x square over 1 plus x square, and is also equal to tan inverse of 2x over 1 minus x square. Okay, we'll see why this is. So I'll begin with the first one. Y sine inverse of x plus cosine inverse of x is pi by 2. So we want to know why it is pi by 2. I'll begin with the left side, call this as the left. Okay, and this is the left. And here let's make some substitution. Instead of sine inverse of x, let's plug it in as p. By definition of inverse trigonometric function, that this means basically sine of p, sine p is x. Now what is x means? X over 1. That's like opposite over hypotenuse. You can create a triangle like this with the angle as the p here. So this is like a p or theta, whatever. I should have taken theta, that's fine. So that's opposite is x, hypotenuse is 1, using the Pythagorean identities. This is square of this, 1 square is 1, minus square of this in x square. So if you know cosine p, we also know, can write down what is cosine of p. So cosine of p is adjacent hypotenuse. Now this time adjacent is square root 1 minus x. Oh, I did forget, I thought I'm proving this one. Okay, we don't need all this. What we need here is, sorry about it. We can, once you get this sine p, this sine p is also same as, we can write cosine of pi by 2 minus p equals x. It's the same reasoning is like this. Suppose this was that, if this is the p, if this is angle p, or let's take it at theta, because we are always taking theta, right? So we can write this angle as theta, this is 90, this becomes 90 minus theta. So if I call this as, let's say, A, B, and C, and if I write sine theta here, sine theta is B over the opposite of hypotenuse, and I can think of this angle, that means cosine of 90 minus theta, and cosine is adjacent over hypotenuse, and here the adjacent for this angle is this b, so you get back your b over c, and it's the same thing. So sine theta is cosine 90 minus theta, and what is 90 is cosine of pi by 2. So if you check here, I just replace sine theta is cosine pi by 2, and then use the definition of cosine inverse of pi by 2 minus theta is cosine inverse of x. Then add theta both sides. So this theta goes away and you get pi by 2 equals theta plus cosine inverse of x. And replace back what is theta, just plug it here. And then that means it is pi by 2 equals sine inverse of x and plus cosine inverse of x. And you get the answer. And that is the right side. Now I want you to try yourself the other tan inverse of and cot inverse and cosecant inverse and secant. It's the same thing. So because of the time, I'll just move on. You can try that yourself. Let's do the next set. Okay, so let's finish this. Oh, the second one. Now, why this formula, right? Call this as 1 and 2. These are 1, 2, and 3. This is just one straight away. So let's see why it is. So what I'm going to do is the left side, let's start with sine inverse of x plus cosine inverse of x. Okay, inverse of sine inverse of x plus sine inverse of. So each time we will replace it by some angle. So let's substitute, instead of sine inverse of x, okay, I'm going to call this as call this as, let's see, alpha. I'll call this as alpha. So sine inverse of A is alpha. This one, let's call it as, beta. We call it as beta. So Greek letters for angle. So this is alpha. By definition of inverse. So sine of alpha. So this will be sine of alpha is going to be x. And this side, sine of beta is going to be y. Now, what is the meaning of x? It means over 1. This means over 1. And if we try to make a triangle like this, and this is the angle. So this is opposite. So opposite over hypotenuse. So this will be our x, and the hypotenuse is going to be 1. And another triangle here is for theta. This is a beta. So for this angle, that's y, and this one is 1. So the question is, how do we find the third side? The third side is always square root. The square the hypotenuse, which is 1 minus square. And the same thing here. This will be square 1 minus y square. So why do we need this? Is because now that you know sine of alpha, so from here we can write cosine. This part we can write it as sine of cosine of alpha. What is cosine of alpha? From here is this is the opposite and that's the adjacent. So cosine is adjacent. Adjacent is square root of 1 minus x squared and divided by hypotenuse. In this case, from here you can write as sine beta. So what is cosine of beta? Cosine of beta is this one. This is adjacent for the beta angle. So 1 minus y squared and 1. There you go. Now if it is divided by 1, I don't even have to write this one, so it's just without. So this is sine alpha, cosine alpha, sine beta, cosine beta. And then you use the compounding formula. What is that? Compounding formula is cosine, so sine of alpha plus beta, so sine of alpha plus beta equals sine of cosine. See? So you just have to replace alpha. So this is alpha and cosine is the beta, and then you replace this sine of alpha. And what is sine alpha? Sine alpha is x, so this is x. And cosine of beta is square root of 1 minus y squared. Cosine alpha is root 1 minus x squared. And sine beta is y. See this is, oh, that sine beta is y. Let's study. And then you can use the definition of inverse trigonometric function, which says if you have sine of n, whatever this angle, that stays the same on the left, alpha, beta, and this goes on the other side as sine inverse of this x square root of 1 minus y squared plus this y square root of 1 minus x squared. And then you replace this alpha, so this alpha is replaced back here, this beta you replace back here, and if you see this alpha, when you replace, alpha is sine inverse of x, that's sine inverse of x. Beta is sine inverse of y right there, and equals sine inverse of x, and that's how you get it. And you can do the same thing for with the minus. So if there was a minus here, you do the same thing. This will be minus. So you have to use minus here. This will be minus. This will be minus. This will be minus, and it works. But if it is cosine, suppose let's say you are working on this cosine inverse, you'll have to use here cosine inverse. You put this equals to alpha. You put this equals beta. You do the same thing. Cosine of alpha plus beta, which is cosine alpha cosine beta minus sine of alpha sine beta. All the steps are the same, and I'm sure you can do it. Finally, let's do the last one. I want you to try that. See if you can, anything strikes you when you look at this. 2 tan inverse of x is, and it's written in 3 different ways. Now you're supposed to use double angle formula there. So sine 2 theta is in terms of tan. So make sure, because on the left side there is a tan inverse, right? So this is tan inverse. Okay, let's finish it off. So, by double angle formula, remember sine 2 theta is 2 tan theta over 1 plus tan square theta. Cosine 2 theta is 1 minus tan square theta over 1 plus tan square theta. And tan 2 theta is 1 minus tan square, 1 plus tan square theta over 1 minus tan square theta. Okay, so this is what we already know, right? So now what I'm going to do is, in this example, tan theta, this tan theta will replace it by, so replace, so we are going to replace tan theta is replaced by x. Okay. Now from here, If I write sine 2 theta is this, sine 2 theta will be, sine 2 theta will be, so this tan theta is replaced by x, so you get 2x plus 1 plus x squared. This cosine 2 theta will be equals 1 minus x squared, because tan theta is x, and you get 1 plus x squared. And this tan 2 theta will be 1 plus x squared and 1 minus x squared. Okay, and then finally, we use the definition of inverse trig. That means if this is the angle, this is the angle, stays 2 theta, but other side you write sine inverse of, same thing here, this 2 theta is cosine inverse of 1 minus x squared over 1 plus x squared, and here this 2 theta equals tan inverse of, and then you will see that replace this theta by, so what is t theta? From here, this angle theta is tan inverse of x. See, because tan theta is x, definition of inverse trig, theta is x. So you replace this theta right here, you replace here, and you replace it right here. So that is 2 tan inverse. Now all these are 2 theta. This also is 2. So I write only once, which is 2 tan inverse of theta. And then you write this one sine inverse of 2x. Okay? The same thing is cosine inverse of 1 minus x squared, 1 plus x squared is same as tan inverse of. And there you go, they're done. So simple. So we need these formulas when you are working on calculus, that is integral, or there are problems where you come across this and you can apply it over there. Hope that helps. So again I repeat, these are more identities to know how they exist, and too many identities. Right, Valerie? Bianca, Natalie, Hugo, Misael and Jocelyn. So I hope this helps to really master the trigonometry part and helps. So practice is the best teacher. Again I repeat, my goal is to make this kind of concepts clear as why do these formulas exist? How do you get them? Where do they come from? And hope we'll continue in the next class. Bye, take care, God bless you.